Hello friends, today I am going to deliver lecture on the topic of equilibrium in strategic form games of an extensive game with perfect information. So first we need to learn what is extensive game with perfect information. So extensive game with perfect information is a game in which we have the information of order. We have information of order. Order means in which order, in what order the player take action. If we know this information, then we say that this game is a extensive game with perfect information. So in any game, if we have the information of order, we know when any player takes some action, then we call such a game an extensive game with perfect information. Next, we will try to find out the equilibrium in this extensive game with perfect information, like we find out the equilibrium in the strategic games. So that is why their topic is equilibrium in a strategic form of extensive game with perfect information. Means we are try to find out the extensive we will try to find out the equilibrium in extensive game using the same technique which we used in the strategic games. Okay, so first I have considered an entry game for the extensive game. So this is a entry game. This is a game of two players. Okay, so in this game we have two players. One player is challenger, another one is incumbent. Okay, so this is a game of market. Okay, so let's say this is a market. Here we have, in this market right now we have only one player, that is incumbent. Okay, and he is a monopolist, means he is the only player in the market right now. Nobody is there in the market other than him. Okay, he is the only player. Now, incumbent is facing a situation in which the other player, that is the challenger, may enter into the market. Okay, so what would happen if challenger enters into the market? Definitely the market share of incumbent will decrease, and his payoff will also decrease, right? So definitely the incumbent never want a challenger to enter into the market, right? But challenger may can enter or may can stay out from the market, right? So this is the game tree of this entry game. So this is the point root node of this game tree is representing the empty history. Empty history means a point at which no one has taken any decision yet. So you can see here, this is the empty point, no one has taken any decision yet. Okay, so now who is playing first? Who will play the first? Definitely the challenger will take the action first. Why? Because challenger may can enter or stay out from the market, right? In response of this, then incumbent will decide what to do. Okay, so who is the player who will take the action first? Challenger. Okay, challenger will take the action first. So you can see here we have the information of order in this game. So that is why this game is an extensive game with perfect information, because here challenger will take the action first. Next, after taking the action by the challenger, the incumbent will take the action. Okay, and challenger is the challenger is the player who will take the action first, and incumbent will take the action next. Okay, so here we have the information of order. So at this point, the challenger will take the action, and what actions are available to the challenger? In and out. Two actions are available. Either he can enter into the market or he will stay out from the market. Now after taking the action of in, means the challenger is entered into the market, what incumbent can do? So at this is the point of history in. History in means we can reach to this point after taking the action of in, means the history of this node is in, and the history of this node is phi. Okay, and history of this node is in. Okay, now at this point incumbent is the player who will take the action, and what actions are available to the player? either he can take accommodate or he can do fight. If he accommodates that challenger into the market, definitely the market share of the incumbent will decrease, and his payoff will also decrease, right? So and challenger entering into the market, so definitely his payoff will increase, right? So as you can see here, the payoff of challenger is 2 and the payoff of incumbent is 1. The payoff of challenger is greater than the payoff of incumbent. Now if incumbent choose the action of fight, what would happen? Means he's fighting with the challenger. So in this case, both the players do fight with each other and both of them will not do business. In this case, both will get the payoff of 0. Okay. Now what would happen if challenger stay out from the market? Means he is not in the market. So he is not in the market, so we don't care about the incumbent whether takes the action of accommodate or the fight. It doesn't we don't need to care about that. Okay. So in this case, obviously when challenger is not in the market, the payoff of the incumbent will be higher and the payoff of the challenger will be less. Okay. And we don't need to care about the action of the incumbent because the challenger already is stay out from the market. So we don't care that the incumbent is fighting or the accommodating. Okay. So this is all about the entry game. Okay. Now we will try to find out the equilibrium. Okay, we will try to find out the equilibrium of this game. Okay, and now we will try to solve this extension game with perfect information using the same method which we use in the strategic games. In the strategic games, we construct a payoff matrix first, and then using the best response function, we will try to find out the equilibrium. Okay, so similarly here, we will construct a payoff matrix first. Okay, since this is a game of 2 players and every player is having 2 actions, so there will be 4 blocks in this payoff matrix. Okay, so this is the side of challenger, and challenger is having 2 actions in, another one is out, and this one is for incumbent, and 2 actions are available, accommodate and fight. Okay, now what will be the value of payoff for the challenger and incumbent when challenger is taking in and incumbent is taking accommodate? So in this case, if we traverse this tree in and accommodate, and what we are getting 2, 1. So 2 is the payoff of challenger and 1 is the payoff of incumbent. Okay. Now what would happen if challenger is taking in and incumbent is taking fight? So both will get the payoff of 0, 0. So here 0, 0. Now what would happen if challenger stay out from the market? Okay, if challenger stay out from the market, then we have 2 possible actions for the incumbent, but we know it will not affect the action of incumbent will not affect the payoff values, right? Either the incumbent can take the action of accommodate or can take the action of fight, but we know the payoff will not be get affected. So in both the cases, the payoff will be same, that is 1, 2. Now in out A, the payoff will be same, the 1, 2, and out fight, the payoff will be same, 1, 2. Okay, so this is the payoff matrix. Okay, which we have constructed for this extension game with perfect information. Now we will try to find out the equilibrium of this game. We know how can we find out an equilibrium when we have given a payoff matrix. So first we need to find out the all possible combinations. What combinations are possible here? The one combination is in, accommodate. Okay, what can be the other combinations? The in, fight, and out, accommodate, and out, fight. So we have 4 possible combinations in this game, and we need to check whether a combination is equilibrium or not. Okay, so we know the method. If this one is a equilibrium, if this in A is a equilibrium, we know the condition. What condition need to be satisfied? The condition that need to be satisfied is B of C A should be equal to N. Means what? The best response for the challenger when the other player is taking accommodated should be in. And what should be the another condition? The best response function for incumbent when the challenger is taking in should be A. Right? If these two conditions are satisfied, then we can say that yes, this in comma A is a Nash equilibrium. So we check for this condition. First, the BCA is equal to in. BCA means the player challenger is taking the action of accommodate, and we will try to find out the best action for the challenger. Okay, so the incumbent is taking accommodate, and if challenger takes in, he will get 2. If challenger takes out, he will get 1. Which one is best here? 2 or the 1? 2 means in. So this condition is satisfied. Okay, now we will check for BI and in Vi in equal to A. Okay, means what? The best response for I for incumbent when the other player, that is challenger, is taking in. Okay, so challenger is taking in here, and we will try to find out the best action for incumbent. So if incumbent take the accommodate, he will get 1. If incumbent take fight, he will get 0. So 1 is best, means accommodate is the best. So this is also satisfying. So we can say that this combination is a equilibrium. Okay, now we will check for in comma fight. So what condition need to be satisfied here? BC fight should be equal to in, and B incumbent in should be equal to fight. Okay, now check it. So here in this case, the challenger is considering that incumbent is doing fight. So which one is best? 0 or the 1? 1 is the best, right? Means out is the best. But here we are getting in. So this condition is not satisfying. So we will not check for the other condition, because this condition is not satisfying. So we can say that this is not a Nash equilibrium. Now we will check for out comma A. So what condition need to be satisfied here? So BC A should be equal to out, and BI out should be equal to accommodate. Okay, we will check for the conditions. So BCA means the challenger is considering that incumbent is taking accommodate. So here this is the column of accommodate. Now what action is best for the challenger? 2 comma 1 in is the best, because here we are getting 2. Okay, so but what we are getting here, we are getting here out. So this condition is not satisfying, and we can say that this is also not a equilibrium. Now we will check for out comma fight. In this out comma fight, what condition need to be satisfied? So BC fight should be equal to out, and BI out should be equal to fight. Now check for the first condition. BC fight means the player challenger is considering that incumbent is taking the action of fight. So which one is best? 0 or 1? 0 or 1? 1 is best, right? So 1 is best, so out is best. So and output is out. This condition is satisfying. Now we will check for BI out, means the incumbent is considering that challenger is taking the action of out. We need to check this row. We need to check this row. Now which one is best? In both the cases he is getting 2, and both are optimal. The accommodate and fight both are same, right? But the output should be fight, right? And we are getting fight also. So this condition is also satisfying. So we can say that this is also a Nash equilibrium. So we have got 2 Nash equilibrium for this game. Okay, but there is a problem in this game. In this method, there is a problem in this method, that the equilibrium which we have got can be reasonable or can be non-reasonable. Now I explain you what is reasonable equilibrium and what is non-reasonable equilibrium. Okay, so in this game, sorry, Okay. So what equilibrium we have got in this game? One is the in comma accommodate, another one is out comma fight. Okay, and I am saying that some equilibrium will be reasonable and another one and some can be unreasonable. I explain you how can we find out that an equilibrium is reasonable or an equilibrium is not reasonable. So a reasonable equilibrium is that equilibrium that is valid for the whole game tree. Okay, now if I check for this in comma a and I check this sub game, if I check for this sub game, for this equilibrium, tell me, is it valid or not? At this point the incumbent is having two actions available, accommodate or fight. Now incumbent if take a, he will get what? 1. If he take fight, he will get 0. So which one is greater? 1 is greater, means the best action for incumbent is accommodate. So here as per this equilibrium we are getting accommodate, right? Now we will check for this sub game, we will check for this sub game. Okay, now here challenger is taking in, then we will reach to this sub game, right? If challenger takes in, then we will reach to this sub game. Okay, and we know the output of this sub game. The output of this sub game is what? The incumbent will take a accommodate. Okay, and we will reach to this point. And what is the payoff of challenger here? The 2 is the payoff of the challenger. Okay, what would happen if challenger stay out from the market? Then he may accommodate or fight. Incumbent may accommodate or fight, and both the cases he will get 1 comma 2 1 comma 2, right? So in the both the cases the challenger will get 1, whatever the incumbent do, but that is for sure that the challenger will get payoff of 1, right? If challenger takes the action of out. But if challenger takes the action of in, we will reach to this sub game, and we know the output of this sub game. The output of this sub game is the incumbent will choose the action of a and the challenger will get the payoff of 2. Now in which action he is getting more, in or the out? In the action of in he is getting 2, and in the action of out he is getting 1. So which one is best? In is the best, right? So means what? This in is also valid for that sub game, right? So this is a reasonable Nash equilibrium. Reasonable Nash equilibrium means a equilibrium which is valid for the whole game tree. Now we will check for out comma fight. Okay, out comma fight. Now again we consider, sorry, now for this combination out comma fight, we again check the same sub games. We need to check this equilibrium for all the sub game of this game tree. Okay, so this is also a sub game, right? Now for this sub game we know the incumbent is having two actions available, accommodate or fight, and we know the incumbent will always choose the accommodate because here is getting 1 and in the case of fight he is getting 0. So 1 is best means he will choose accommodate. But as per this equilibrium, the player incumbent is choosing what? The player choosing is fighting, which is not best for the incumbent. So this cannot be a equilibrium. This is equilibrium as per the strategic game, but this is not a equilibrium. This is not a reasonable equilibrium because this does not make any sense. This equilibrium is not making any sense. Okay, so that is why this is a non-reasonable Nash equilibrium. So what is the conclusion? The conclusion here is, if we apply the method which we use in the strategic games to find out the equilibrium in an extensive game with perfect information, then we can find out the reasonable and non-reasonable Nash equilibrium. both. So what is the conclusion here? If we find out the equilibrium in an extensive game with perfect information using the method which we use in the strategic games, then the equilibrium which we will get can be a reasonable or can be non-reasonable Nash equilibrium. So we need to adopt some other methods by which we can find out only the reasonable Nash equilibrium. So that I will discuss in my next lecture. Thank you.